extremely cool, as always, Academy session. My name is Alina Bonadonna, and I will be a moderator and host for today. Uh, just extremely welcome to invite our beautiful speaker with 25 years of experience in food safety and microbiology field, Anett Winkler. Thank you, Anett, for coming and accepting our invitation. How are you doing, Anett?
I'm doing very well. Thanks for asking, and thanks for the invitation to talk here. Really appreciate it.
By the way, guys, let us know just if you hear us good, see us good, if connection is smooth, so we can continue. Just put plus in the chat room so we know that all is fine. And Anett, where are you currently based?
Well, actually, I'm currently based in Munich in Germany. However, having said that, that's a home office, so there is not really a production facility behind, which means that I'm traveling a lot to the production locations.
Yeah, basically there are advantages and disadvantages of home office, kind of.
That's very true. Yeah.
Yeah. I'm based in Zurich, and you guys, where are you from, and who is listening to us today? We are really very curious because normally NEMIS Academy community is very broad, and we have people from United States, from UK, from Australia, from different time zones. So while you are typing from where who is, I think we are good to start, right? Are you ready, Anett?
For me, it's fine to start. What comes in
Perfect.
and out?
Perfect, guys. So I will share a screen and we can slowly start our presentation. Yeah, just let me know if the screen appeared already and if it's fine.
For me, at least, I can see it.
Okay, great. So basically, I give you microphone and camera time, Anett, and I will be your kind of remote controller. And you guys, after the presentation and during the presentation, you can type the spiciest questions, the most interesting question we will read out after the presentation, and definitely Anett will be happy to answer.
Let's put it that way. I will try to answer. If I can answer, will depend on the question. But let's start talking about environmental monitoring, opportunities and challenges. So what is on the menu, or what's the agenda for today? On the next slide, or going further, so to speak. Environmental monitoring, opportunities and challenges. Yeah, but why do we do it at all? Is there any meaning? Is there any purpose behind? Then there are some examples and also some approaches on how best to approach them. And all of those come with opportunities, but they might also come, and they certainly do, with some challenges. So moving to the next one, going into the purpose. Why would we even do environmental monitoring? And maybe to clarify it here, environmental monitoring here is meant to be monitoring of the environment with respect to the microbial flora. So it's a microbiological environmental monitoring, because I know the term is being very widely used also in completely different connections and combinations. But here we talk about environmental monitoring of your microbial flora in the environment within the food production. So now the first purpose you have is, as with a lot of other stuff, you have legal requirements you need to follow. That is an example shown on the next slide. That is because, as you know, I'm based in Munich, which is in Germany and which is in the European Union. There is EC legislation 2073 from 2005, and highlighted here is samples shall be taken from processing areas and equipment, which relates to this microbial environmental monitoring, under certain conditions. And here are the two that are explicitly spelled out on a legal framework. Ready-to-eat foods which may pose a risk with respect to Listeria monocytogenes, and also manufacturers of dried infant formula or dried food for specific medical purposes. So this is clearly regulated, and this is certainly one of the things or one of the productions where you need to do environmental monitoring. Then let's look further. What's the next one? So you fulfill your legal obligations, but you also use environmental monitoring to potentially verify your preventive maintenance. So your preventive maintenance of your equipment, and looking therefore at your equipment design and how to improve it. An example what potentially can go wrong, you see on the next slide. For some of you who may remember, in 2018, we did have an outbreak on frozen vegetables, to be clear, on frozen corn for Listeria monocytogenes. And when they looked into the root causes, was at the freezing plant, and there was a persistent presence of Listeria in one of the two freezing tunnels. So that links back to equipment monitoring of the equipment and maintenance of the equipment, also to prevent condensation, to have adequate cleaning schedules. With links into the next one. Why else would we use environmental monitoring? We can use it to verify our cleaning, and we can verify with it so-called clean breaks, which is a terminology that's mostly coming out of the US, and means you have your production, you have a validated and verified cleaning, potentially combined with a disinfection, and afterwards, basically, you have a new start, a new production that is not linked from a microbiological point of view to the production before. Or what you can also use it for, and that's actually a very good point, you can validate longer run times. You can take samples during running productions and then consider, okay, can I run longer than maybe 8 hours? Can I run maybe 12 hours or 16 hours without a cleaning? So this is what it can do for you as well. But let's look again at some examples where it didn't go too well, which is on the next slide. There was a Listeria outbreak in Germany, and not only in Germany, but it originated in Germany from this company called Wilke. And that is related to ready-to-eat meats. They thought at the beginning it was only linked to a slicer, but then they found out, oh, it was coming from different sources, and they found it all over the plant, which suggested extensive hygiene breaches, as you see highlighted here. And that means there was not really a good environmental monitoring program in place there. So it was not detected earlier. Also, extensive hygiene breaches also links into sanitation and cleaning breaches. Now, that has been now 5 years ago. So you think industry and everyone could have learned from that. Now you see on the next slide, it's still rather actual, or it seems to be rather actual, with the ongoing outbreak with boar's head in the US, where it links again to dairy meat, sausage, hot dogs, etc. And they found significant sanitation failures at boar's head facility. You can look it up in the source yourself. And there were some questions asked by Food Safety News, and surprise, they were linked to a question: environmental monitoring. Which lab was used? What was the SAP? What do they have a standard operating procedure for the environmental testing program? So you see, there is the link between cleaning and sanitation and environmental monitoring, what you can use it for to prevent such things to happen in the first place. Let's go further. Is there anything else we can do with environmental monitoring? You can also verify your zoning, your segregation between raw, between processed area. You can verify good manufacturing practices, employee practices, material movements. Further, without going into more details, here it comes with the zoning and the GMP and movements. Outbreaks from the 80s up to 22. You see this outbreak on Salmonella typhimurium in contaminated chocolate. That has been in the 80s in Norway. And when they looked into it, they found the very same Salmonella in those little birds that is living in this area and in the chocolate, where bird activity have also been seen in the warehouses before. So you wonder how the Salmonella made its way from the bird to the chocolate. A very famous one again in the US is the one with the puffed rice cereal, the Salmonella agona one. In 98, there was an outbreak. Then they did all precautions. However, same production line. And they did some changes in infrastructure where they might have disturbed the Salmonella still living in the dust in the area, and had the same outbreak in 2008 again. Now the area is permanently closed and it's continuously surveyed for that one. In 22, there was an outbreak on peanut butter, Salmonella Senftenberg again in the US, and there was environmental isolate from 2010 that matched the outbreak strain. So obviously Salmonella, which is really an artist in surviving dry conditions for years, had made it successfully between the 2010 and 22 from the environment to the product. Then the next one, please. So this is it all together. Legal, cleaning, preventive maintenance, equipment design, verify zoning, segregation, and GMP. Let's go further into more details of environmental monitoring here. Outbreak detection. Think about opportunities and challenges. Now, with the modern technologies, especially the genomic ones like whole genome sequencing, it opens a completely new field. It opens a completely new view here. Here you can just see on the left side from the FDA, they stated how many genomes were sequenced. Now, this arrow here stops in 21. It's not getting less. It's actually more than, it's millions at the moment. And all those global databases, there are actually 3 big ones. They exchange all data on a daily basis. So once you put a sequence in, it will be available after 24 hours through the whole world. Now, what does it enable it? And the CDC made this very nice picture here, that whole genome sequencing prevents Listeria illness. I would rather say prevents maybe further spread or prevents a higher number of Listeria illnesses, because what WGS does, it allows you to compare isolates from very distinct areas, even not only in one country, but spanning over continents. So what happens then is you solve outbreaks with much fewer cases, and therefore also, of course, you solve more outbreaks. When you just simply think about it, in the past, without genomic, then all the outbreaks were solved using epidemiology and other microbiological methods. Now, it first took the effort to identify an outbreak. Now, by WHO, an outbreak is identified with 2 or more persons getting sick. However, imagine you have 1 person getting sick in one country and 1 person getting sick in another country. Who in the past would have made the link between those 2 cases epidemiological wise? Would be extremely difficult and wrong. Now, when you do the sequencing, it's very clear. You would say, boy, this is the same sequence, so we'll need to follow up on that. So you do solve fewer cases, and with that, of course, you have more outbreaks, because you can have now outbreaks with 2, 4, 5 persons, which was really not the case like 10, 15 years ago. So in that respect, to prevent this from happening, you can also see environmental monitoring as an excellent prevention strategy, because what it also does it helps you to identify your problems before they end up in your product. And we all know that product testing has limitations, and there's nothing you want to rely on. In that respect, environmental monitoring can really give you an, let's say, early alert. Next one then. And it is a risk-based approach. That is important to understand what is the difference between a risk and a hazard outlined here. Clearly, legal requirements is what you have to fulfill. However, for everything else, any other production, you take a risk-based approach. And that is not only what you identify as a hazard, but also is the probability of that hazard taking place. And that is an important difference, because otherwise what can happen, you can, let's say, identify 5 hazards, and then you look for all of those 5. However, 4 of them or 3 of them have an extremely low probability even occurring in your production or in your environment. Then you spend a lot of money, you spend a lot of time on some things that at the end don't have value for you. So this is really an important thing to consider, to stay focused. Because when you stay focused, your likelihood of detecting your real problems are much higher than when you don't. There's one note here for FSSC 22000 for environmental monitoring. In that respect, it also includes spoilage microorganisms. So it's not only focusing on safety, like outbreaks, foodborne outbreaks, but it also includes spoilage, and that would be not covered here in that approach. So you also need to think, okay, I have my risks related to food safety, but I also have spoilage, which I also might need certain environmental monitoring parameters on. Next one to go through. So now for environmental monitoring, when you want to set it up and you need to do a risk assessment, where would you start? And here's just stated where you could start. It's very simple. You start from the very beginning. You start from the raw materials, then you look at your product. Then also you look, remember, it's a verification of zoning, of your segregation. And when you look at your segregation, you definitely, for microbiology, you pay attention to your validated pathogen reduction step and consider a recontamination potential afterwards. So 2 examples below. One is chocolate production. And after cocoa roasting or after milk pasteurization, whatever goes into the chocolate, this is a fairly open process. So there is recontamination potential. And because of that, environmental monitoring is very important in that kind of production. Also, when you consider the hazards identified for chocolate, being salmonella as the main and prevalent one. Now, very different from chocolate is vegetable oils. Vegetable oils, and especially refined vegetable oils, is really a closed process for 2 reasons. First of all, the first process, deodorization, is high temperature vacuum, so you can't have it open to the environment, otherwise the process would not run. And later you want to prevent the oil from oxidation. So again, you don't want air in contact with this oil. Therefore, it's an extremely closed process. So environmental monitoring from a risk-based perspective might have a much lesser purpose here in the oil production than it has in chocolate. It might not even be needed for the safety. Maybe you want to do it for other reasons, but it's such a closed process that environment has very little role to play. Next one. To consider what are the potential exposures to the environment. You consider your air. You also consider within your line, you have sieves or magnets potentially, and you can have manual dosing of minor ingredients. Those are all, let's say, interactions with the environments where you can see, okay, there could be an introduction of microbes that also clearly relates to maintenance, repairs, clear to constructions, and not to forget cleaning activities Remember at the beginning, it was also said verify cleaning activities. Now here you see an interesting risk associated with cleaning methods. And you see the more you spray, the more or you increase your risk, which when you think through seems to be very clear, because when you push or spray something, then what happens is you push or spray the dust around, and you also push and spray the microbes around. So a lot of especially compressed air or high jets, what they do is basically they more and more distribute all the microbes that are in the original area. Next one. Then the next consideration is you have all those activities and individual points. Okay, you want to set up a routine. So this is your routine you generally want to survey for whatever reason. Then you also have investigation sampling points. For instance, when you have an accident, or when you have, as mentioned here, leaking pipes, water in a dry zone. Sometimes you have emergency, like you have a sprinkler going on. So there you need to investigate, did the environment change because of that event? It's the same for maintenance, repairs, constructions. And even more, when you have an out of specification or positive result on a pathogen, then clearly you need to take more samples to find out, okay, where did it come from or where did it spread to, which is important for your actions. Then when we go further, once you have the points, you wonder which microorganisms you want to target. Pathogens, indicators, or spoilage. Here you see different names of microorganisms. Some might sound familiar, some not so much. When you look at the indicators, they contain Enterobacteriaceae. One member is E. coli. And you see also a pathogen that's named E. coli, but it's a specific one. And I tried to illustrate it on the next slide. In terms of clouds, here you see the pathogens in red and the indicators in black. Generic E. coli is not a pathogen. Generic E. coli is an indicator, often used as indicator of fecal conditions, but it's not a pathogen. 90% of all E. coli are normal commensals of your intestines, of any digestive system of warm-blooded animals. There's only a very small subgroup that is really pathogenic. If you want to look for those pathogenic E. coli, you need to have special methods, by the way. Next one, which links into the tests and the methods. You base a lot of decisions on results of either your internal or external laboratory. So it's important to make sure the results are reliable. You want to do that? Use validated methods. Are you sure your laboratory is qualified for that? That means, is the method verified in the laboratory? So it's not the same. Validation and verification are two different steps. Validation is the design that the method works as such, and the verification really refers to that the method works in the hand of the laboratories. So it's important to have both to get a reliable result. And also be aware, what is your limit of detection and what's your method uncertainty? In microbiology, often you see is absence as reported. In reality, you cannot report absence. You can report not detected, because each method has a limit of detection, has a limit of quantification, has a measurement uncertainty. So there's no such term like absence. It's only you cannot detect it with the method you have used for the matrix you have investigated. So keep this in mind when you think about your results and what kind of decisions you base on them. Next one. Here are also some examples what can go wrong. That was for Salmonella. So there was an ongoing investigation, and only by whole genome sequencing it was revealed that the isolate that came out of a chocolate finished product was actually not from the product, but was a laboratory contamination from a proficiency test that was performed in this laboratory just around the same time. So be aware that you also need to be able to characterize the findings you have in order to make sure they are true positives, or is this potentially a laboratory contamination? I'm not saying that this happens often, but I'm saying it needs to be excluded. Next one. Also, remember at the very beginning, I showed you the purpose of environmental monitoring in terms of verify zoning and verify segregation. And you've seen the outbreak results with resident strains being there for like about 10 years. And here's another example. That was an infant formula, Salmonella Puna, France and Spain. And the isolates between 2010 and 2018, so again, eight years apart, showed to be the same by sequencing. This is the discriminatory power you can only reach by whole genome sequencing. And that is what we can use today to look at our findings. You know, when you think about environmental monitoring, what do you make with the data? It's not just to collect them and put them in a drawer. It's really to work with those data and see trends, see shifts, and also find out, do I also have the same strain that causes me problems, or do I have reoccurrent events? That is a very important answer for the potential root cause, and then also linking to your actions, because actions will be different for resident versus newly introduced ones. Next one. You want to set up a plan? Here are a few steps that might help you how you can do this from a practical perspective. So first step, look at your layout, look at your zoning. Then in the second step, determine your locations. Think about high traffic areas, hard to clean, but I think I have something to come later on as well. It's important that you think about the environment as a microbe. So where can you hide and where can you, how to say, transport it with? And where can you grow? Then the step 3, make a detailed description. Often it's not the same person taking the samples all the time. There might be different persons, there might be a turnover, there might be different shifts. So it's important to make sure when you identify a sampling point, it's clearly always the same. In step 4, links to step 3, make a clear description. Next one. Often in food productions, you have zone 1 to 4 described. Those are not the zones you use in the zoning of the plant, like in raw, ready to eat, or medium hygiene, however you call them. No, those are the zones you use for environmental monitoring, starting from closest to the product contact, to very remote areas, even outside production, like offices and the canteen. And then you can identify how many samples you want to take to survey your environment in that case, and then divide it between the different zones, depending on which manufacturing zone you're on, as an example. Next one. And then you also look at the type of risk you have in the different zones of the plant. Not the environmental monitoring zones, but in your production zones. What kind of cleaning method? What is the humidity? How easy is it to clean there? Is there potential of cross-contamination? So is the product open to the environment or not? Remember, example, chocolate versus oil. Any historical results you have, even from finished product, any risks you see from outbreaks, literature, that all goes into a certain risk score with description. At the next slide. Then you come to step 6, where you finally get your frequency and time of sampling. Now, sampling times is really driven by your purpose. You want to verify your cleaning, then you sample before startup, after your cleaning and disinfection. You want to survey your environment, so to speak, to verify your zoning, then you sample at least 2 to 4 hours to production, and you also sample at the end of the production. So this is where the timing is important also for your purpose. You need to keep that in mind as well. Next one. Now, then clearly you need to determine your surface area. If you sample, the floor on the equipment, cleaning tools, whatever, how do you sample? You see on the left side the little stick swabs. They're usually the cheapest, but honestly, they are not standard to the extent that they are only very well suitable for small areas where there are small cracks to reach. For those, they are good. But if you think about the bigger areas you have to sample, then you'd better take sponge stick swabs or sponges. Next one. And then you start performing your sampling rounds. Here's important, really look for the microorganisms. Think what are the most likely places where they can hide. It's not before the equipment, it's below the equipment, because this sometimes is missed out by cleaning. You might have this kind of wall connections, and there you can have like false ceilings with some empty spaces behind. Empty spaces always mean there can material hide, there can water hide. So those are good areas to take samples. Floor cracks as well, drains, as well as cleaning tools. Because remember, when you do cleaning, the first rule of cleaning is something else gets dirty. So don't forget the tools you clean with. Next one. And then you have your results. You can adjust your sampling method and plan. Also, very important, do something with your results, trend them, and then you can adjust your sampling plan and method again. Getting more into some of those details. Next one. So that is the conclusion with very important, I think, for everyone is when you do environmental monitoring, the first thing is ask you why you do it, and then be ready for all answers. So be prepared that the answer, or let's say the test result, is not what you expected, and be ready for actions. Don't stop thinking once you get this answer, because then it's usually too late. And I think the last slide is simply a few more literature hints. Yeah, guidance documents, you can get more details. And with that, many thanks for staying on.
Thank you so much, Anett. It was really very resourceful and interesting presentation. And I really welcome everyone to ask questions. But if you don't mind, the first one is mine. Yeah, I'm really curious. Can rapid methods meet the standards set by authorities on behalf of environmental monitoring?
You mean, can rapid methods be used by authorities as well?
I would say not just used, but is it something that can meet standards and can be recognized?
Yes, as long as they are validated and verified. It's actually, when you look in, at least in the EU, there is the case that when you look at the 2073, the one which I cited before, there are methods, there are the reference methods cited, but Article 5 also clearly says that you can use alternative methods, but they need to be validated and verified accordingly, and it gives some more specifics. Yeah, and actually, I know in the EU there is now a draft regulation that even official laboratories can use alternative, or might be able to use alternative methods under those circumstances or preconditions. I shouldn't say circumstance, but preconditions. So yes, validation, verification is key, with some specifics really clearly mentioned in the legislation.
Good. And when it comes to sampling, because you mentioned it as well, and what proves more effective, swabbing or sponges?
That's a good question. In terms of picking up microbes, it depends a lot on the operator and on the sampling technique. So you can pick up the same with a swab or a sponge, or you can pick up very different amounts. Again, as I said, that depends on the operator how they sample, but it also depends on the surface. Is it wet or dry? There are different transfer rates. And what I mentioned in the presentation, important is also what is the kind of sample you want to take. When I want to take a large surface area, a swab will be much less effective because it will not pick up as much from this huge area as a sponge did, simply because it has a very limited small surface.
Mhm. Yeah, so basically it depends on the surface
It
testing.
depends. Yeah, it depends on the surface, and clearly, what is also important for all those sampling devices, they also need to be validated for the purpose. Because you can imagine when you think, I take them for cleaning verification, there might be cleaning residues on the surfaces. Now, is the dilution liquid or is the moisturizing liquid capable of, let's say, overcoming this potentially inhibitory properties of a cleaning liquid? So is it inactivating it? That is an important point to consider.
Yeah. Okay. Thank you. And also, it was very interesting slide. One-off interesting slide regarding pathogen detection and hygiene control. And in terms of considering pathogen and versus hygiene indicator, is ATP alone sufficient? And how does the differentiation between Listeria monocytogenes and Listeria spp impact monitoring practices?
There are two questions.
Kind of, yeah, I can.
Okay, let's first go to ATP.
ATP,
Now,
yeah, is it
yeah,
sufficient?
no,
Sufficient,
yeah,
yeah.
the short answer is a no. The reason is ATP is measuring something really different than specific microbiological methods. I mean, ATP is basically the energy source of all cells. It doesn't really matter if it's a somatic cell from a cow, if it's a human cell, or if it's a bacterial cell, they all contain ATP. So the first question is also when I use ATP, and it's often used for cleaning verification because it's very quick. But then my question would be, do I have ATP there in the first place? Because if I have a highly processed material, it might not contain sufficient ATP to give a signal. Then what would it tell me? I would have a negative before and after. So that's not really meaningful. And then again, it's far too unspecific. It's not related to any microbes, but it has a good role when it comes to cleaning verification in some of the wet processing. However, again, then you need to validate it specifically. It's usually not good enough to use a certain RLU threshold because it's given by a manufacturer. And it also depends again on the surface and on the material and on your cleaning. So that's the first part.
Should I
So I
repeat?
would always do this microbes, Listeria monocytogenes and Listeria species. Again, Listeria species is an indicator, and once I find them, I might also consider that there is I need to consider that there is a potential of having Listeria monocytogenes there as well. So for environmental monitoring, I think Listeria species is the better choice because it gives you an early warning potentially before you face Listeria monocytogenes. Although clearly you cannot exclude it unless you continue with the analysis. And there are clearly tests that can give you a species and then you can further differentiate if you want.
Okay, yeah. And also something that we touched together before going live, the digitalization. How does it influence currently the change in environmental monitoring, and what's the current tools? And in general, this topic is very interesting and so broad. I'm just curious to know how does it work in your experience in currently.
Yeah, I think you mentioned it before as a topic on its own, so I'm not going to go
Yeah.
into a lot of those details. But the thing is, digitalization can be a big support and help in setting up, maintaining, and documenting all the actions you do around environmental monitoring. There are software programs on the market, so software solutions you can buy. If you want, you can do it in-house if you have the expertise. I've seen very nice digitalized tools that were developed in-house. It's all possible. What it does not take from you, and that refers to everything you do as a manufacturer, it does not take from you the responsibility. At the end of the day, the responsibility lies with you. So you need to make sure the input into the system and the output are really not only related, are giving you the results or giving you the views, not the results, because the results come in independently, but the views you need. So this is important. So someone needs to have the oversight. All those systems, including artificial intelligence, can give you perfect patterns, but they don't give you a causality. So you still need a human mind behind that understands how microbes, how to say, proliferate, grow, and spread to make sense of the patterns that you can detect with digital tools.
Yeah. AI is actually currently mainstream in every in every sphere, I would say, not just in environmental monitoring.
Absolutely.
Definitely. Yeah, and I'm also curious to know, is there any specific formula from you, maybe personally, that incorporates key factors such as, for example, product type, batch volume, production time, etc., to determine the outcome, like monitoring frequency and the quantity of environmental monitoring?
I think that's one of the, it's an interesting question, because I would say that it's more dependent on your production in terms of product and how open the production is than it is really on the volume of the batches you produce, and the complexity of the production. I mean, if I have a very small line, then obviously I have not so many points, because I have only a very limited area I need to survey. But when I have huge production lines, adjacent lines, I also have many more people. I have more material movement, and this is what I need. What I need to monitor there as well. And I have bigger equipment, which might be more difficult to clean, or depending on how the cleanability, how the hygienic design of your equipment is, then if you have a perfect hygienic design, then your cleanability might not be so much of an issue. And you can even with visual inspection achieve a lot. You don't necessarily need then a lot of microbiological samples.
Yeah, actually, you mentioned already hygienic design. This is my next question. And does the implementation of hygienic design result in a reduction of environmental monitoring samples, particularly in facilities with aging infrastructure?
The aging infrastructure is different, let's say, from hygienic design of equipment. So you still, then you have an aging infrastructure and your segregation or zoning is not adequate, then that still demands certain amount of environmental monitoring data, again, depending on the risk towards your product and process. Yeah, but when clearly when you have both an aging infrastructure and old equipment, then that multiplies your environmental monitoring requirements. Yeah.
Yeah, definitely. You know, Anett, I would ask you 100,000 more questions again, but we are kind of limited in our time. So thank you so much for presentation. If there are no more questions, you can anyway, guys, reach out to info@nemistechacademy.com and ask question. I will forward it to Anett and she will be able to answer it as soon as she has time. But As a closing remark, I would love to thank to everyone who attended our webinar today, also Anett for accepting our invitation, and I hope that it's not the last one, not the last session. And just be tuned with our further webinars. The next one is coming 10th of October, and we will talk about restoring consumer confidence in the food supply chain. The speaker is Brian Ronholm, the current FDA employer, and he will share the best practices, especially related to US market. And everyone who had a beautiful lunch break or will have some, I wish you amazing day, a good week ahead, and see you soon. Bye.
Thank you. Bye bye.